Hello, everyone. Welcome to SoloCon and welcome to our talk on GitOps and controllers, along with using it with Service Mesh and how it can make your life easier. I'm going to pass it along to Alex to go ahead and do some introductions.
Hey everyone, my name is Alex Lee. I'm a field engineer based out of San Francisco, supporting the West Coast here. Prior to joining Solo, I spent some time at Red Hat and Mesosphere, focused on container orchestration technology, specifically Kubernetes.
And my name is Marino Wijay. I am part of the developer relations and advocacy team here at Solo. So I focus on helping the community embrace some more of the service mesh technologies that we have here, along with some of the other great things that we're working on here at Solo. I used to work at VMware and I spent some time both in the networking and security space, along with the DevOps space with VMware Tanzu. Excited to be here to talk to you about Glue Mesh and how it works with GitOps. So let's get right into it. So one of the most interesting things that we see when it comes to Istio is the way we go about managing Istio for, let's say, a single cluster or a single Kubernetes cluster. And we may want to consider something like taking the declarative approach to simplify how we go about configuring how microservices transact inside of that Kubernetes cluster. And so when we think about it, within a cluster, it might be easy to medium in difficulty to manage artifacts or resources that reside in that cluster for Istio and for Kubernetes. But what we also have to consider is the potential for scale and how that would create a lot more complexity in how we go about managing. So let's think about it this way. What happens if we were asked to go ahead and create a secondary cluster or a tertiary cluster to support our applications or our microservices? Could we potentially leverage something like Git and version control to help with that? Absolutely. So in this talk, Alex and I will cover off the approach to declarative configuration using GitOps and how that applies to using Glue Mesh or service mesh technologies and how that can simplify your operations. We'll also cover off a brief demo just so that you can visualize how this all works and see how the configuration is laid out across different clusters and how that interacts with both Istio, Glue Mesh, as well as our GitOps controller. So when we look at this cluster, or in this diagram right here, we have a single Kubernetes cluster running Istio, and this could be backed on any cloud provider. Single cluster Istio is very simple. It's an easy way to get started. It's actually the best way to kind of break in and understand how to use Istio to leverage things like traffic management, observability, and the built-in security. Now, when we consider having to manage these resources that Istio provides to us, like, for example, a virtual service or a destination rule, for a few microservices across a few namespaces, this is not that difficult. But where it becomes highly challenging is when we have to scale to manage multiple clusters. So let's think of it in the lens of having to run kubectl and istioctl across whatever cluster we're using to stand up the environment, make sure it's ready for Istio, make sure it's ready to support multi-cluster Istio, and then go on to proceed to try and establish, let's say, a shared root of trust. Establishing, let's say, a common root CA or a common root certificate authority can be challenging because you now have to consider how all of the different microservices within your clusters do communicate. And so you then become the custodian for having to be responsible for certificate rotation and management. And that in itself becomes very troublesome and quite painful to manage. The other thing to consider is how you set up your access policies and how you go about allowing different services within your cluster to communicate with other services across other clusters. And the final piece is addressing things like role-based access control, allowing what services can take action on what other services or what accounts can do what they need to from an authorization standpoint. Now, we've kind of understood the fact that with a single cluster, managing things like virtual services, destination rules, service entries, like to access external endpoints, can be pretty straightforward for a few microservices. But when we try to scale to multiple clusters, it becomes very hard, as I previously mentioned. So the most challenging part is having to create a set of virtual services, destination rules, and even authorization policies for 3 microservices across, let's say, 3 clusters. Now you're going to have to manage this 9 times over. And so maybe you might consider using something like a version control system to help manage and facilitate some of the approach to making changes or syncing changes across those clusters. But the other thing to consider is, even if you had separate isolated clusters and you used a level of Git to help automate it, you still have the challenge of your certificate rotation across those different clusters. So when we look at this deeply, if we are assumed to have a single cluster and a few microservices, we know it's easy to manage. And when we continue to iterate against that app, add more microservices, it's going to grow. So that means our varying Istio resources will also grow alongside that. When we also think about the certificate management within a cluster, that in itself is not difficult, but having to set up MTLS between, let's say, the reviews service in one cluster and then the rating service in another cluster means we also have to go about establishing that common root of trust and then also establishing a pattern for certificate rotation. So one of the ways we could try to help simplify this is if we use a GitOps approach and a GitOps controller, which means we now feed our configurations in through Git. Those changes that get fed in are recognized and synced by the Git controller or the GitOps controller, and then in turn reflected inside of the Kubernetes cluster. Now, this is not doing everything for us. All it's really doing is automating some of the work. Instead of us having to go run kubectl against every single cluster, basically the GitOps controller does that on behalf of us for us. So it's syncing those changes, honoring those changes, which means that your Istio resources that you've gone about to configure will change alongside of it. But again, as this scales, you also have to start thinking about how you set up things like access policies or authorization policies across the different clusters for different service-to-service communication. At the same time, not every cluster is going to have the same level of needs. So you might have certain clusters within your environment that may need to access external services using service entries. And then you also then have to go and define and figure out where destination rules will correspond and where they align to across the different, let's say, virtual services that you've set up. The other thing too is you're now spending more time having to manage that than you are allowing your traffic to flow around within your operating environment. So one thing to consider is maybe you want to consider a further level of abstraction, something that can understand these resources and then additionally translate them for you. You configure that single resource, it goes on to create the additional resources that Istio would normally produce when you need to set up things for routing or when you need to set up security. But it all starts with some abstraction. And so let's think about the glue mesh abstraction. So glue mesh is a well-designed API that is intent specific. It really considers things like, the source and destination of objects to determine how best to align that policy. In the case of glue mesh and in our example here, we actually have a custom resource definition or a CRD defined that basically is our traffic policy that gets translated into a virtual service and destination rule in Istio, but for multiple instances of it. So what we're doing here is we're defining a route. So if we think of the world of like network routing or IP routing, we have to define a route, and then we have to also define how we get there, or what our exit point is, or our exit interface, whatever it might be. In our case here, we're defining that route. and we're telling it where we're trying to go. So we may be originating from somewhere in the glue mesh namespace, then anything that has a label that says type north south means that we'll be allowed to route to anything that is containing the label app reviews. So I'm just basically creating a policy that says use these identifiers to match on this particular criteria or condition to allow you to route to this destination based off of that criteria or set of conditions. And then furthermore, within this policy, I'm able to define the weight or distribution by which I send my traffic requests. So perhaps based off of where I'm coming from, I may be sent to, let's say, reviews or the review service in one cluster or cluster one. I may be sent to maybe the review service in cluster two based off of other route information. So what this is really helping us with is creating a single CRD that can replace a number of Istio CRDs. This is Glue Mesh. It's a powerful API that provides a variety of functions. What we're seeing here is a traffic splitting kind of function, but there is also the ability to do things like traffic shifting, fault injection. We can inject some delay so that we can ensure certain microservices come up before others to prevent any sort of chicken and egg situation. We can also have Glue Mesh program the proxy or the sidecar to do some retries in the event of failed requests. We also have the ability to implement like WAF functionality. So we can block certain types of traffic and prevent any sort of harm that comes into the network or into your microservices network. And you can also do things like external authorization and tie into systems like OPA so that you can provide some enhanced authorization mechanisms to various microservices. So it effectively creates a very simplistic manner in which you can manage your multiple Kubernetes clusters, all that run, they all run Istio. They all run their own version of Istio. But what's really neat is you're not managing the individual instances or resources that Istio needs to look at, or the Istio CRDs. You're not having to manage that. You're managing these higher level constructs, these abstractions called traffic policies or access policies, or even virtual destinations. And those are understood by the Glue Mesh controller, which then will translate those into Istio resources. But then the other part of it too is that you're still also leveraging GitOps here, because when you feed your changes into Git, the GitOps controller is going to pick up on that, and then it's going to in turn reflect those changes. It's going to sync those changes into the Kubernetes clusters, which then are going to be picked up by the Glue Mesh controller in order to translate those into Istio resources. So this is significant simplification of managing all those different Istio resources using Glue Mesh CRDs. So what we've effectively done is simplified your management of your Kubernetes clusters in Istio at scale using the Glue Mesh approach. And with that, this basically allows us to segue into this opportunity to allow Alex to show you how this all works. One thing I will point out is if you notice this bar here, in one of the previous diagrams I showed you, this bar was further up top, and it was basically pointing out the fact that there was a demarcation point in the amount of resources we manage. So if we actually went back a bit, it's further up here, which means I am actually having to manage a lot more resources within my Istio environments. Whereas looking at this diagram over here, the demarcation point means that I only manage these particular resources. The Glue Mesh controller or a Glue Mesh management controller then becomes responsible for understanding these resources and managing everything below. That way, I'm not here having to sit here and manage them individually. This simplifies my overall approach to management. This simplifies my operations. It streamlines how I build my policies, both for traffic and access, and then how I define my routing. So with that, I'm going to pass it over to Alex to take over and show us the demo. Go ahead, Alex.
Yeah, thanks, Marino. So let's go ahead and hop into the demo portion of this. Just on the page here is the slide depicting the architecture that we're trying to accomplish here, essentially leveraging GitOps alongside integrated with the Glue Mesh management controller in order to provide that line of demarcation. You can see clearly here that under that dotted line, we're going to allow those lower level resources within cluster 1, cluster 2, and cluster 3 to be managed and synced through GitOps, as well as using Kubernetes controllers, such as the GitOps controller and Glue Mesh management controller in this case. And then, by doing that and allowing, software to handle the management and automation of configuration, we're going to allow our DevOps team and our SRE team to focus on the higher level intent, which is essentially what source and destination that you want to configure policy on, right? So traffic policy in our case here. Over here in my environments, I have kind of set up a similar example, cluster 1, cluster 2, and cluster 3 using the book info example. In cluster 1, I have just reviews version 1 set up. In cluster 2, I have reviews version 2, and cluster 3, I have reviews version 3. This is just really simply to show that here I have 3 clusters all showing, the same app, but a little bit different, right? In the sense of no stars, black stars, and red stars. And if I go to my bookstore application, you can see this is my cluster 1 running on GKE with no stars or for the reviews. In cluster 2, black stars. And in cluster 3, I have red stars. So this is just a typical single cluster Istio setup registered to Glue Mesh so that we can actually see, from a single pane of glass, what our cluster topology looks like, our multiple cluster topology. And here you can see that each Istio ingress gateway is only serving the services within their one cluster, right? So when it comes to going into multi-cluster in this scenario, what you would have to do in a upstream Istio build would be to configure the access policies across the cluster. You would have to unify the root trust across all these clusters in order to make them aware. And this can be cumbersome, especially if you're kind of talking, more than a few clusters to tens, if not hundreds of clusters, like some of our customers have. In this example, what we can do is configure what we call a virtual mesh. And the virtual mesh here will unify our root trust across our clusters selected by label selectors or direct reference itself. So here's what a virtual mesh CRD looks like. Pretty simple. And as you can see here, it is all synced in Git so that Git can actually use that as our source of truth. But to dive a little bit deeper into the virtual mesh, here we can see that I want to unify the root trust between 2 of my meshes in this case, just cluster 1 and cluster 2, but leave cluster 3 alone. And in this case, I want to just, for simplicity's sake, set the global access policy on my virtual mesh as disabled for now. Let me go ahead and configure that. And what you'll see if I go to my Glue Mesh UI is that I'm going from 3 meshes initially, 3 individual Istio meshes. And here you can see cluster 1's running version 1.11.3, cluster 2 is running version 1.11.4, and cluster 3 is running version 1.11.5, just to make a point. You can see by configuring that virtual mesh object that I just showed you, we have now kicked off the glue mesh in order to unify the root trust between cluster 1 and cluster 2. And you can see that it's already happening. Now I have a virtual mesh that contains cluster 1 and cluster 2. I can see what's in my virtual mesh, what policy rules that I've created, what workloads are running inside that virtual mesh that can now be routed together. And I can also actually see through the glue mesh dashboard what versions of meshes are in my virtual mesh, right? So, so in this case, 111.3 and 111.4. Now, if I go back to this GitHub repo, I can show you how I can now use a simplified CRD to handle that multi-cluster routing using a route table and a traffic policy like Marino showed, right? So in my route table here, I have defined that in this particular north-south traffic, any traffic going to the product page on cluster 1 or in cluster 2 gets split 50-50. And then from there, as far as the east-west traffic goes within the clusters, I am declaring my intent, right? So essentially, what is the source where this connection is coming from? So in my case, the north-south ingress gateway selected by a label selector. And this is really important because, you know, as I onboard from one to few to many clusters, labels become pretty important here so that I can handle the discovery without having to hard code any you know, specific reference or anything like that. If cluster 3 or cluster 4, cluster 5 comes into play and they have a north-south ingress gateway with the label type north-south, glue mesh will pick this up and start routing traffic immediately. If I want to actually get pretty specific with that though, glue mesh is capable of it as well. So in this case, you know, in the destination, I can select by direct reference, but I could also tie it to a label match as well. So in this case, this cube service matcher is matching all the clusters for specifically cluster 1 or cluster 2 with the label app reviews as our destination. So there's our source, our destination, and then the policy or the intent that we want to create. And in this case is a traffic shift from reviews, anything going to the destination, which is reviews. I want to shift that traffic to reviews across cluster 1 and cluster 2 at a 50-50 rate. Now that I've already configured that, I can hop back over to my cluster 1 book info application that was only showing no reviews earlier. And if I refresh a couple times, you can already see that this is now serving traffic across 2 clusters, cluster 1 and cluster 2, and you can see that through the no stars and black stars that you see on the screen here. If I go into the cluster 2 ingress gateway, you can see the same. However, in cluster 3, since I have not added that or selected that as part of my virtual mesh, you can see that that default, you know, Istio install stays preserved. In that case, completely outside of the virtual mesh itself and still is showing red stars. If we pop back into the glue mesh UI and go to the graph, we can actually see this, right? So let me select all my clusters. And here you can see that cluster 1 and cluster 2 have been connected together here with the shared root trust. And you can actually see that in the UI with these lock icons across the clusters. So you can see MTLS is enabled across multi-cluster in this case. And if I so choose with the traffic policy, I can direct traffic freely across the two clusters. Right now, I don't have RBAC set up, but I will hop to that in a moment just to show how easy it is. Again, using label selectors to set access policies to lock this down. Over in my cluster 3, you can see that the Istio ingress gateway in cluster 3 is only communicating with the services in cluster 3, and that's how we saw just red stars showing up there. To tie this all back to how GitOps works, everything that you see in this demo so far has been synced with Git as our source of truth, using Argo CD as our GitOps controller. So here, switching over to adding a third, that third mesh into our cluster, essentially onboarding that third cluster into our virtual mesh is as simple as switching a Git branch, right? So let me show you. If I go back into Git and I pop over to my 3 clusters branch, you can see the same CRDs in the same space, which is just the management cluster being used. And essentially all I'm doing is adding another reference or label in the mix, right? So I'm moving from a virtual mesh that only had cluster 1 and cluster 2 now to a virtual mesh that has cluster 1, 2, and 3. When it comes to the route itself, here I have now kind of added the cluster 1, cluster 2, and cluster 3 north-south traffic set with a weighted distribution of 30, 30, and 40 to cluster 3. And then in my traffic policy, I have also now added in the service match to match services in cluster 3 with the label app reviews. And then I have now defined my policy to shift that traffic from 50-50 to cluster 1 and cluster 2 to 30, 30, and 40 across all review services in my multi-cluster setup. Now that I have everything defined in Git, it's as simply as pushing a change through your CI that changes that branch. In this case, I'm going to do that manually. So in Argo CD, I'm going to switch over to the 3 cluster branch and let Argo sync that. What you'll see here is that Argo CD is now synced to my 3 cluster branch, meaning that the virtual mesh here now, if I scroll down, will show that it actually has all 3 meshes being selected. If I pop back over into my Glue Mesh UI, you can actually see that the process of uniting that root CA across all 3 clusters has already completed. Inside my virtual mesh, I have cluster 1 with Istio 111.3, cluster 2 with Istio 111.4, and cluster 3 with Istio 111.5. And if I pop back into my application now and refresh, what I should see is that I should see a no stars, black stars, and red stars being evenly distributed at the weights that I selected, 30, 30, and 40, over across all 3 clusters here. So cluster 2, you can see, has all 3 reviews now, and so does cluster 3. So now I have essentially onboarded Team 3's cluster, which has the new Red Stars app, into my virtual mesh transparently without my end user knowing that this service is actually split across 3 clusters. And I can actually view this in the UI. So let's go kind of double click on what our app looks like in the back end. You can see how all these connections get extremely complex to set up, and think about this with 3 clusters. Think about it with 50 to 100, right? The web of connections is going to drastically scale, meaning that the amount of configuration that I would have to manage in an upstream Istio setup would drastically scale alongside with that. Now, lastly, what I wanted to show is how simple it is now that I have all of the connections across my 3 clusters working to set up access control policies so that I can lock this down. If I pop over back into Git, I can show you how all of that kind of gets done with just an access policy or a couple access policies that also define your intent, which is source, destination, and you know, where I want to basically select and put my access policies. So in this case, here is the book info access policy. The source selects the Cube service account for the ingress gateway, and the destination matches to any application within the default namespace with the label service product page. So this, again, with label matchers, allows you to better select or easily scale, because you can select based off labels, but you also, you know, in a case where you need to lock down to a specific resource, can select based off of a specific reference itself. You can see that all these access policies follow the same pattern. Choose your source, choose the destination of where the policy should go.
This almost reads like a little bit of a firewall rule set, right, Alex?
Yeah, a lot like that. So it makes it simple to select things, especially based off labels. So why don't we go ahead and show again now, once I've got that set up and I can just sync that to Git, what you'll see is access policies being created to glue management plane. And from there, back to this diagram here, the operator or SRE team defines the access policy that gets submitted to Glue Mesh, and Glue Mesh, instead of a human being, will then translate that access policy over to the lower level Istio resources across my clusters. Again, this, you know, becomes a lot more sense at scale when you're talking about 50 to, you know, or tens, you know, or tens of clusters, right? Having to go into each cluster and create the individual authentication policies to make this happen, to make the connections, you know, secure, would be pretty untenable. If I pop back over into the Glue Mesh UI, you can see that my policy has been implemented. You can actually click on the policy rules themselves, so you can see, you know, the multiple sources of which this policy has selected, and the multiple destinations which this policy enacts on, right? So in this case, cluster 1, cluster 2, cluster 3 ingress as the source, and cluster 1, 2, and 3 product page as the destination. If I pop back into my application, you can see with these particular access policies, I'm still, everything is still working. And however, if you were to not have something that was under an access policy, you would be routed to an RBAC access denied page. So hopefully this helps you understand a little bit more about how to leverage GitOps as well with a controller in order to simplify operations across multi-cluster and specifically multi-cluster service mesh.
That was great, Alex. Awesome. Well, thank you, everyone. Really do appreciate you taking the part of SoloCon and looking into our presentation. Hope you enjoy the other ones out there. Take care.
Thanks, everyone.